Hello, in this video we will show how to do Poisson regression in R programming. So first we will talk a little bit about what is generalized linear models. So we have learned linear regression. So in the linear regression, we will estimate the unit change in the independent variables on the response variable. And the response variable usually continuous and should be approximately normally distributed. But sometimes response variables are not normally distributed and very skewed departure from at least approximately normal distribution. So this can be categorical variables, or outcome variables can be counting variables. So in the case of counting variables, usually we can use Poisson regression model. So this is a generalized linear model. So on the left side, it is the response variables and with a link function called G. So with this link function, so we can model this part change based on the unit change in independent variables. In R, we can use a function called GLM. So this is a big family functions. In this function, we can set the family. Family is the probability type of the variables and a link function. So these options depends on different module. So Poisson distribution is to predict an outcome variable representing counts from a set of continuous or categorical predictor variables. And in the Poisson regression model, the link function is a log type. So log counts on the left side of this formula. So next we show an example from robust base package in R, and we consider the impact of an anti-epileptic drug treatment on the number of seizures occurring over an 8-week period following initiation of therapy. So here we focus on the drug treatment as the independent variables, and the response variable is the seizures, number of seizures occurring. And from the data, there are several independent variables like a Y sum. This is a response variable. And this is a treatment condition. Treatment are two types: placebo or treatment, and age for this response, and number of seizures reported in the baseline. So these three variables are independent variables. So we will show how to implement Poisson regression in R. So first, you have to install this package called robust base in R. Then we load this package's data called epilepsy. Then we show the variables in this data frame. So there are 8, 9, 10, 11, total 11 variables, and we show summary of the 6 to 9, these 4 variables. So this is the base variables, minimum 6 and maximum 151, and age minimum 18, maximum 42, and treatment categorical. Placebo has 28 observations, and plug-by treatment 31 observations. Then Y sum is the response variable we are interested in, minimum 0 and maximum 302. So from this summary data, you can see at least these variables very skewed. So to prove this, we just plot load ggplot2 library, and we plot plot y-sum, these response variables, in a histogram. So you can see this is very skewed on the right side. This is not normally distributed. And we also plot a box plot for y-sum and with respect to different values of treatment. Here we can say for the different values, placebo, placebo of treatment, the response variables have different shape, and here we can know that their variance are very different. This is a very big variance, and this is relatively small. So in this case, the usual linear regression model cannot be used, because linear regression, we assume that the dependent variable has same variance with the different values of independent variables, right? But here, this assumption does not match. But for the Poisson regression model, it has no problem for different variance. So next we can fit this module with the Poisson regression. So we use GLM and y-sum on the left side and the base age treatment on the right side. The data and the family is Poisson. So family Poisson has default link function with a log type. So we does not need to set option here. Next we can show summary of the results of this Poisson regression. So all the coefficients with the intercepts significant, and we show these coefficients. So because the link function is a log type, so this one unit change in independent variables will result in 1 unit change in the log of these counts, these seizures, right? So we can use exponential of these coefficients. So it's quite clear. So for the treatment from 0 to 1 unit change, then the results of the seizures occurring will be 85% or 86%. So which means the setting of the treatment will result in 14% less in this occurring of seizures, right? Thanks for watching.